Okay, today is about inverses. Does this function pass the vertical line test? Yes. Does it pass the horizontal line test? Do you even know what the horizontal line test is? Probably not. Let me explain it to you. Excuse me, there's a whole bunch of people talking. Need your attention. All right, thank you. The vertical line test, you've known forever. And it's just, does this touch more than once when I move it like this? No, because one input, like x equals 3 here, whatever we're at here, is supposed to only have one output. But the horizontal line test does the same exact thing with a horizontal line. And you'll catch functions like this, which is a function, won't pass it. Get how that wouldn't pass the horizontal line test? So what does that mean? That means it's a function, but it's not a special function. A special function would be called a one-to-one function. That's the official name for special functions. They're extra special because ones that can pass both the vertical and the horizontal line test, they have an inverse that's also a function. Okay, so I'm going to think of this as like a parent-child thing. Okay, so let's say that we have a function and it is this. You get how a child oftentimes even looks a little bit like the parent, okay, but is definitely different. Okay, so let's say we have the inverse of this. First thing you'd have to know about the inverse is that it's a reflection across the line y equals x. Do you remember that from honors higher algebra or not? Maybe you never were taught that. It's possible. Do you know that that is the line y equals x, at least? Think about that. That line that runs at a 45-degree angle like that? Okay. All right. So by now you should have sketched this. If you haven't already, sketch it now and turn your iPad my way. Thank you. I can see several of you have already got this sketched. See, yours is good. All right, I'm going to let you get caught up for a second. By now you should have sketched this. And what I'm looking for is an inverse of this. If you remember nothing else from today, please remember that an inverse is about switching the x and the y around. So this spot right here, which might have been the spot 0, 2. If I switch the x and the y around, what would it be? 2, 0, and that's going to be this spot over here. Why is that a big deal? Because it's part of the inverse. Let me draw the rest of the inverse and see if this makes sense to you. Get how it's a reflection across the line y equals x. All right, since some of you drifting into a coma after lunch, how many of you just had lunch? All right, so this is the food coma kicking in. Or I'm being really boring, but I'm trying not to be. I had loud music when you walked in to kind of keep you awake. All right, so back to, this is f of x, and this is its inverse. Do you know what the little symbol for inverse is? That's the symbol for inverse. Now, one thing to watch out for. This is different than reciprocal. If I have 5 and I have its inverse, that would be completely different than its reciprocal. Its reciprocal would be 1/5. Don't get reciprocal confused with inverse. I do it all the time. I get them confused in my head, but you got to understand, this is not the graph of 1 over x. Okay. So reciprocals and inverses are definitely different things. All right. That little symbol is saying do the inverse. What does the inverse mean? Switch x and y. So if you pick any point on this, let's say that I said the point 7, 9 is on the green function, then do you get a comparable point over here of what, 9, 7 would have to be on the other one. Is this making more sense to you as time goes on? Okay. All right, let's name the beginning and end points on this thing. Let's say that I said this spot right here was at -2, -2. That spot right there, -2, -2. How do you switch around? First of all, I'm wrong. That can't be right. Okay, that's not -2, -2. What is it? Yeah, -2, +2. Okay, that's important because I was like, wait a minute, my mind is blowing because if I have to reverse it and it's the same thing, that's not making sense to me. So what's that point got to be? 2, -2. Does that make sense to you? All right. And let's name the very last point on this green function here. This spot. Let's say it's 8, 10 or something like that. I'd like you to tell me the domain of the green one and the range of the green. Hint, domain is about the x's, range is about the y's. The domain and range of the green one. Because I think you're going to find something interesting happens. My goals for today are to teach you how to find an inverse by looking at its graph. And that would be to just reflect across this line. It's not that complicated. If I can get you to understand that these are reflections over that line, then I've got that part. Number 2, I have to tell you what a one-to-one function is. That's a special kind of function that passes both the vertical line test and the horizontal line test. Would these guys pass both the vertical and the horizontal line test? Yeah. So then that means they're a special function called a one-to-one function. And that means that their inverse is a function. The green one's inverse is the black one. The black one's inverse is the green one. Do you get that both of these have an inverse that is a function? All right. Now, what's the domain of the green one? Domain is about the x's, right? Did you say -2 to 7? Raise your hand if you said that. Uh-oh, what did I do? What am I doing wrong? Oh, to 8. Sorry. That's not the endpoint. This is the endpoint right here. -2 to 8. How many of you said that? Okay, good. Then the range, the y part. So 2 is the lowest it goes to what? 10 brackets. Did I get that right? Now, before, did I do something wrong there? I'm just making sure. From 2 to 10, isn't that right? The lowest the green one goes is 2, and then the highest it goes was this spot, which was 8, 10. So that's why and it's also just the y's, from 2 to 10. Okay, now here's the question. Without even looking at the picture, I can know the domain and range of the black one. Think about it. Because x and y got switched, x becomes the y, domain becomes the range. So the domain of this one would have to be the range of this one. And therefore, I just copy it down here. And whatever the range on this one was, 2 to 10, becomes the domain on that one. And if you actually look, it works. See, domain on this one, 2 to, oh, I never actually graphed that point. It would have to be the point 10, 8, because it's the inverse of that point. So it's going to be from 2 to 10 and -2 to 8, just like it says. All right, next up, a parabola. Function, true or false? True. Does it have an inverse? Just to clarify, everything has an inverse. All you have to do is flip it over that line. Yes, that's the point. Say that one more time. Yes, it has an inverse, but the inverse isn't a function. All right, watch this. That part flipping over the line is fairly easy. Yet I'm going to reflect this part now, and it goes right there. And then the part that's really kind of funky, I want to make that better. The part that's really kind of funky is this part reflecting over that line. Ends up right there. It's like a parabola turned sideways. Why? Because this is y equals x squared, and I think I told you this other one before. Do you remember it? X equals y squared. And notice that their stuff got switched. The one that was being squared is now not, and vice versa. It's like x and y got flip-flopped. All right, so is this a one-to-one function? No, it's not one of those special functions because it didn't pass both the vertical and the horizontal line tests. What that means is everything has a function, but this guy's function, everything has an inverse. But this guy's inverse is the red one, and the inverse doesn't pass the vertical line test. I think some of you think that that means that it can't exist. It can exist. It's fine. It's just not a function. And by the way, if you're not a function, what are you? Starts with an R. Relation. Okay. Function or not a function? Function, because it passes the vertical line test. Special function, called a one-to-one function. Do you really think it passes the horizontal line test? I'm going to show you a spot I want you to consider. Ooh, hits it 3 times. Doesn't pass the horizontal line test. Therefore, it doesn't have an inverse. True or false? False. Therefore, this black one is not a one-to-one function. True. Okay. So this is not one of those super special functions because it doesn't pass the horizontal line test. If it had passed, if I just tweak it a little bit, I can make it pass. And then, there, now it's going to just barely pass the vertical and horizontal line tests, and therefore it has an inverse. Well, they always do. No, it has an inverse that is a function. All right. Let's say I had an equation for this thing, and it's got some little terms in it and stuff. So let's say I said it was x to the third plus 2x plus, let's say the y-intercept here is like 4. Okay, now let's say that was right. I'm not saying it is, but let's say that was the exact right equation for it. What's another way I could prove that this was a function? What was that other way? We get it tested on, there was actually 3 ways to tell if something was a function. 1, does it pass the vertical line test? 2, and everybody forgets about this one. There's only one y equals, then it's a function. If there's y equals this and y equals that, if you need 2 to explain the function, then it's not a function. Do you remember the deal where if you solve it down for a y equals equation and there's only 1, then it's a function? I think a lot of people have forgotten that one, and I just wanted to remind you. So if I show you an equation here, function or not a function? Function, because it's solved for y and there's only one of them. How would it ever not be a function? What if it was x equals that and there's a y squared somewhere in it? Do you get if I solve it for y, this would have 2 answers because it's got a squared on the y. You get what I'm saying? At the end, you'd have to take the square root to get that fixed, and then you'd have absolute value, which would cause you to get 2 answers, and you'd have y equals this and y equals that, which would mean it's not a function. So this one's not a function. All right. So they're going to show you in your homework today like something like this. Is that a function or not a function? And the first reaction a lot of kids have is, well, I can't graph it, so I can't tell if it passes a vertical line test or not. Not at the point. I can tell it's a function right now. Why? Because there's only one y, and it says y equals whatever. Okay. All right. Now, next question is, what's this thing's inverse? Well, then, so far, all I've taught you is you'd graph it and reflect it across what line? Y equals x. But there's a lot faster way. Okay, so here's the faster way to get this guy's inverse. To get this guy's inverse, do you remember me telling you that if there was only one thing to remember about inverses, that it was that, what did I say again? X and Y get reversed. Okay. If that's true, somebody tell me what you think I need to do to find the inverse to this thing. What? Kind of. Do something first. Any help them out? Yes, I can tell you we're onto it. X, Y, and now solve for that. Solve for Y. All right, this is going to be a bit of a pain, but this is the question. X equals 4 minus 3y plus 7 all over 10. Hint, first thing I would do, okay, sorry, let's make it just 10 instead of 110. You're right, I had 110. Got a little twitchy. I had a shake at McDonald's. They had this large shake, which was vanilla on the bottom and chocolate on the top. And so I actually saw the lady like putting the whipped cream on top of it. I said, huh, you guys got like 2-layer shakes now? And she's like, oh crap, that wasn't supposed to happen. So she goes to get the chocolate shake, and I'm like, what are you going to do with that shake? And so they let me take the shake. So, anyway. All right. So I'm a little hopped up on sugar right now, but it'll be okay. So that, remember me telling you to get rid of fractions? Top 20 skill, clear fractions. This one's actually pretty simple because there's only one denominator. So times 10. I hope this was something you could have done without me. Notice I'm not going to times both of these by 10 because timesing by 10 on the outside of this, you might say, is going to just cancel that anyways. But I'm not going to put parentheses like that. I'm just going to go cancels. Yay. So 10x equals 40 minus 3y plus 7. And again, what am I trying to solve for? You'll always solve for y. That's why we switch x and y around, so that you can then solve for the right variable. Solve for y. Can I just finish this up? Let me finish. Is there a mistake? If the original question was like this and there wasn't a parentheses, now I get what you're saying. There is always imaginary parentheses, but if, let me think this through. Actually, you might be right. The original question was as I wrote it. There are imaginary parentheses around the top. Imaginary parentheses are real enough that they would make that negative distribute. You're right. Thank you. Absolutely right. So I should put a parenthesis here, and that's going to force me to have a negative on that 7. Good call. Okay, now I'm going to continue and get this y alone. So I'm going to put the negative 7 and the 40 together. 10x equals negative 3y plus 32, nope, 33. And then I'm going to subtract 33 from both sides. And I get 10x minus 33 equals negative 3y. Whew. And then I'm almost done. Divide by negative 3. Divide by negative 3. Notice I'm doing it in all 3 spots. A lot of people would have just put one big line with divided by negative 3 there. And the problem is it's harder to tell what your slope is then. I'm done. Negative 10/3 x plus, notice this is a negative divided by a negative 11. That is the inverse of that other function. What did I do? You switch x and y and solve for y. Actually, they usually call it a 3-step process, and I don't want you to be confused by that because it's usually just a 2-step process. The 3-step process goes like this. They give you a function, and they usually call it f of x. And the first step is to just change f of x into y. And then switch x and y, and then solve for y. If you really caught that, try this one. Y equals 2x minus 11 over 3. I'd like you to find the inverse of that. Need some paper? All right. Here you go. Okay. Step 1, I like to switch x and y around first. Then I'm going to clear the fractions. Multiply everything by 3. And the 3 goes here, and the 3 goes here, and that cancels that. Some people are confused about why I don't multiply both the top parts by 3. If I had, I would just have to factor the 3 back out again before I canceled it. You know what I mean? All right. So now I got 3x equals 2y minus 11, adding 11 to both sides. 3x plus 11 equals 2y, dividing everything by 2. Notice me doing it separately so I can see the slope. Y equals 3 halves x plus 11 halves. There's the y-intercept, there's the slope, and this thing is a function. I know without even looking at it, because it's only one y equals, so it's got to be a function. So that means it's original, the one that preceded this, the one I started with, must have been what kind of a function? One-to-one function. All right. I think you've learned everything that you need to know. Now, the algebra can get really icky. Let me show you one where the algebra gets icky. And this will be like an algebra check test to see who's really, really good at algebra. Find the inverse of that. This will once again show pre-calc concepts aren't that hard. What am I doing? Switching x and y and solving. It's the algebra. It's always the algebra. That's why kids that ace my top 20 or even, just get like 17s out of 20 are usually fine in here. And it's the kids that struggle along with the like 9s or 10s or 12s out of 20. Your algebra skills are really bad. That means it's harder for you because this class is very algebra intensive. Okay, so here's a logical argument for you. Oh, I'm going to pause for a second. Okay, so that's how I start. X's and Y's get flipped. Remember me saying how to clear that fraction, except it's a variable. But you still multiply both sides by y. How many of you started properly? Then it's xy or yx, doesn't matter, equals y plus 2. And how do you solve that for y? Somebody in here is going to know. What do you think? You didn't do it right, you're saying? No, I know you can do it. Just make sure your answer comes out the same as mine. There's one way to do it. You do not get to divide both sides by y, because if you did that, just hold on. If you did that, do you agree that y is a variable and y could be 0, and you just divided both sides by 0? I can't do that. Unless you want to drag around with you a little, oh, but this equation only works if y is not equal to 0. So you don't want to do that. So don't do that. Subtract y from both sides. But why would you do that? Let's see if anybody is clued in yet. Just wait, and we'll see if your answer comes up right. Yes? Nope. No, that's not the answer. You can get y alone. I feel like one of those people who say, how many times do I have to tell you what my favorite saying is and why? So, if you can factor it, you should. I can factor that. Y comes out, x minus 1 equals 2, and then look at that, y's alone, and now I can divide both sides by x minus 1. Why is it my favorite saying? Because it usually saves the day on the really hard questions. There's your answer. Y equals 2 over x minus 1. If you can factor it, you should. Okay, look for that. On the ACT also, I've seen this several times, where you factor it and the ACT problem becomes like, whoa, now it's super easy because I factored this thing and something canceled, or again, the reason is my favorite saying. If I was a calculus teacher, probably wouldn't be because, well, I know they use it a lot in calculus, but there's probably some other thing that helps so much in calculus, but this is the thing that keeps coming back, is like, if you get stuck on a hard problem, I was kind of hoping somebody would pull that one out, but try it anyways. Have it on your list of things you can try when things get tough. Like I could try factoring it, I guess. And then it works. Okay. All right, so you've learned a bunch of stuff. Let's summarize it real quick. Does this have an inverse? Yes. Is this red thing a function? Yes, it passes the vertical line test, and everything has an inverse. Okay, its inverse is a reflection across what line? It's a reflection across the line y equals x. I would hate to have to draw that, but if I had to, I'd take one point at a time. I'd take this point, for instance, which looks to me like it might be 8, 8, and I would say on its inverse would, what? If I reverse 8 and 8, wouldn't 8, 8 have to be on its inverse? Yes, it's going to intersect with its inverse. Why? Because it's probably going to do one of these kind of numbers where I would have to, oh, I see, I know why this is throwing us off. My line y equals x would have to go through it, wouldn't it? That line y equals x would have to go right through the point 8, 8. That's why we were having trouble picturing it. Okay, so let's back that off again. I'm going to move my line y equals, oh no, there it is. And if that's the spot, 8, 8, it doesn't have to move because it intersects with its inverse because it's right on the line. Then I'd try to go like this and reflect one little part at a time. That was pretty bad. I'm going to try again. And then it has to hit there. So there, I got my first part done. Then I'm going to cross the line again because that spot shares it with its inverse. And then, ooh, that spot, that's important. Would you agree that might be like, if that's 8, this must be like 0, 4 or something like that? Then thus 0.4, 0 would have to be on the graph too, right? All right. And then this spot's important. I know that spot. I can say that that's 0, 4. So what has to be on the other graph? Okay, you're right. 0, -4. So -4, 0. That is not perfect.
No, it's -4, 0. The new point is
-4, 0. Happy now?
Yes.
Okay. So can you reflect to get the inverse? Yes. But when you've got this nasty looking equation, and you don't even know what it looks like. So you don't even know. You don't even know. You ever see that Will Ferrell clip? Where he says, you don't even know. All right, I'll have to show you that later. Anyway, you don't even know what that looks like. I don't know what that looks like. Nobody in here knows what that looks like. So how am I supposed to tell if it's a function? Is there only one y equals? So it's a function. Cool. Then how about this? is its inverse a function? I don't know until I see its inverse equation. So do I graph it and then do the reflect over the line thing? No. I do x and y get reversed, and then at the end of this one, you'd have a nasty one because it'd be one of those ones where you got to get it all to one side and then factor it. Because if you can factor it, you should. All right. Good. I think you've learned what. Now, do I know for sure if this is a one-to-one function? I don't know until I see its inverse. Once I see its inverse and I make sure that its inverse is just y equals something, then I can know, oh, it's for sure an inverse. Or it's, sorry, its function, its inverse is a function. There we go. Okay. I suspect that its inverse is a function, which would mean this is a one-to-one function. All right, let's do your homework together. Let's everybody find it. Look in the notes for today. That's not it. Hold on. I'm going to pause for a sec. Okay. So I'm going to tell you something to skip. It's going to basically be do the ones that are circled, but not exactly. So anyway, cross off these top two. We'll start with number 4. We did something very like number 4. What was the first thing I said after switch x and y? This is normally y, right? So we switch it to x, and this is y. Clear the fraction. So multiply everything by 5. And then this one's not one of the really icky ones. When we get really icky is where there's an extra y on the bottom. It's not like you can't do it. You still clear the fraction and everything, but you got to get it all factored to get it done. This will be a good one for you. You should do that one, and we can skip number 10. So basically, 2 on this page. Numbers 4 and 7 on that page. Okay, then let's go on to this page. 12-minute warning. It's a good thing we're in homework. And on this one, we will do number 12. And I want you to note something. That's an artificial what? Domain. And do you remember there was a special formula that we used when we did functions inside of other functions? It was the inside function intersected with blah, blah, blah. Don't let that leave your brain too far. We don't need it today, but that test is coming. When? Thursday. So the stuff, yep, I just taught you, the stuff I just taught you, I actually went far enough so that in theory we could test Wednesday, but we aren't going to. We're going to take tomorrow, we'll just do something that's a little twist on what we just did today, so basically not really new stuff. The next day, complete review, and then Thursday test, okay? So what did we learn before this stuff about inverses that you could get tested on? Before this, we were doing things like, what is f of g of x, right? Where you have one function swallow the other function, and then what's the inverse of that? And you remember the formula for that would have been, you take the domain of which one? Inside, which is g in this case, intersected with g of x in domain of f. Yes, that's a formula you're going to want to know how to do. But it's not used today. But I just want to remind you, that's the domain. That's what that is. That's saying we only want you to use this formula when x is less than or equal to -4. It's an artificial domain. They said, even though normally you can put in any number you want, we want you to use that. All right. So then when you swap, when you flip-flop x and y, do you get that x used to be x, but now it's y? Okay. Anyway, do number 12. Skip 13. They're unluckies anyways. We can skip 15. That's too easy. I think you should do 17. That's one of those evil kind where there's an x on the bottom, and so you'll have to do a little more work when you do the swap and you try to solve for y. You get how there's y's on top and the bottom. Again, you think of it as a fraction. How do you clear the fraction? Multiply by the denominator. Then you'll have y's running all over the place. See if you can corral them all onto one side and factor. Okay, and then we'll get to this last page. Yeah, I only need you to try one of these. Just, it's good for you to think in terms of lots of variables. Cancel those. Try that one. It is assigned. I want you to do it. And there is an answer key, so don't cry too loud. What? Yeah, the other one's a challenge, so it's... not necessary. Okay. We have some time to work. Feel free to ask me questions if you have them.